Greetings from SJB Institute of Technology. I am Anita. Today we are going to learn about rectangular microstrip patch antenna design and simulation of 5.8 gigahertz, which is used for ISM band using quarter wave transformer method. So in the previous session, as we have seen about 2.4 gigahertz, so now we will see about the quarter wave transformer design, because the impedance of the patch antenna at the edges you can calculate using the formula, which is around 285 ohms, 280 to 200 to 280 ohms. So it is now for this type of patch antenna we are getting for around 258 ohms. Then the feed line impedance is 50 ohms. As these two impedances were not matched, so we will make using between a quarter wave transformer to match the impedance uh, of feed line with the patch. So this is the formula. Z1 quarter wave transformer impedance would be square root of feed line impedance and input impedance. Uh, the feed line impedance is 50 ohms and Rn is 258 ohms. So now this is a design for 5.8 gigahertz using the same substrate, that is FR4 material with epsilon R value as 4.3, which is designed at 5.8 gigahertz on a substrate of with the height of the substrate as 1.6 mm. So you can make use, as I have told you in the last class, you can make use of pasternet.com to calculate the length and width of the patch antenna, dielectric constant as well as the height you need to specify. Now the frequency of operation is 5.8 gigahertz. So you do calculate, it will show you. So 15 using these formulas it will evaluate. So 15.88 is the width and 11.88 is the length of the patch antenna. Ground plane and substrate to be chosen as twice. Here I am choosing a 35 cross 35 mm around twice. The thickness of the copper clad and height of the substrate as usual of 1.6 mm and 0.035 mm. Feed width to be calculated. A feed width, that means the feed line impedance is 50 ohms. I need to it is of a microstrip, so you can make use internet to calculate. So you can go to RF calculators, everything RF. In that RF calculator, go to microstrip calculator. In the microstrip calculator, I am supposed to evaluate a microstrip width calculator. So you need to enter the target impedance. The target impedance is 50 ohms and the trace thickness is 0.035 mm and the dielectric height is of 1.6 mm and the relative dielectric constant 4.3. If you do calculate the width around 3 mm or 3.08, even you can calculate using CST software also. So it is around 3.08 mm. The quarter wavelength transformer length would be that you can calculate based on the impedance. The impedance which we have got for the quarter wave is square root of 258 into 15, which will give you around 113 ohms. With that impedance, if I for that impedance I need to evaluate the width of the quarter wave. So the width of the quarter wave again by using the same. So the target impedance, it's now square root of 258 and 250, which will give you 113 ohm. So rest all were same. So if you do evaluate, 0.493 mm is the width. So 0.493 mm is the quarter wave transformer width. Quarter wave length is lambda g by 4. Lambda for the operating frequency 5.8 gigahertz is this much, and guided wavelength lambda g is 24.93. Lambda g by 4, if you do evaluate, you will get 6.23 mm. So as now we got to know all the parameters, now we can simulate and see the uh, 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 transfer wave using a CST software. Go to project, same like microwave antennas, then planar type, which we are supposed to do, time domain, millimeter. The frequency range now you can choose as 5 to 6 gigahertz. So don't mark monitors right now. Click on finish, it will open a different windows. Now first step is to make it easy. Parameter list you define. So all the parameters whatever you have, you define it. So the thickness is 0.035 mm, and the height is 1.6 mm. Height of the substrate is 1.6 mm. Then I am defining the substrate length and width. Substrate length is 35 cross 35, which I am considering. Substrate width is 35 cross 35. Then patch length and patch width, you can define PL and PW. So PL value, patch length is patch length is 11.88 mm. So it is 11.88, and patch width, new parameter, patch width is 15.88 mm. Then new parameter, feed width, feed line width is 3.08 mm. So then next quarter, now coming to the quarter wave transformer in between. Quarter wave transformer width is width and length I need to specify. Quarter wave transformer width is 0.493 and 6.23. So width is 0.493. Then another parameter, quarter wave transformer length. So quarter wave transformer length 6.23 mm. 6.23 mm. So now I have defined all the parameters. Patch length, patch width, quarter wave transformer, impedance, substrate, everything parameters have been defined. Now I can go with starting the simulation. Go to modeling, click on brick. Then first we'll start with the ground plane. So ground plane, which is defined at the horizon. So minus SW by 2 along the x-axis width, minus SW by 2 to SW by 2. So minus SL by 2 to SL by 2. Length along the x-axis. I started from 0 to thickness T. Then choose the material from the library, so which is a copper material. So copper, anyone you can choose. Click on load. So now click on OK. So now you can observe the patch has got created. Then again go to modeling, click on escape, then you will get a solid. Define it as a substrate. Then as I am defining, minus SW by 2 to SW by 2 along x-axis. Along length, along y-axis, minus SL by 2 to SL by 2. Then thickness is upon the substrate and upon the ground plane I am supposed to insert a substrate T plus H. Then it is not a FR, it is not a copper material, it is FR4 material. Choose FR material, FR4 material. I have chosen. Click on OK. So you can observe below you have a ground plane, above upon that you have a ground substrate. So now again upon that you need to create a patch. So patch, then patch length and width. So along the x-axis minus PW by 2 to PW by 2. Width, so minus PL by 2 to PL by 2. Define the parameters. So start from the horizon. Horizon, you have a copper clad T, and on the substrate T plus H will be minimum. So maximum will be T plus H plus. So now the material is no longer FR4, it is copper. Click on OK. So you can observe, so ground plane, substrate and patch. So now you are supposed to draw a quarter wave transformer. So quarter wave transformer, define the length and width. So along x-axis width, minus Q W by 2 to QW by 2. I should start from the length should be, I should start from patch, so that's why minus PL by 2 to minus PL by 2 minus QL, so QL. So minimum maximum will be same. So Z plus H, T plus H to, so I should start from the ground plane T plus H plus T. So now it is copper, click on OK. Now you can observe the quarter wave transformer which has got created. So now feed line I am supposed to create. So click on modeling and click, you will get a window, so which is defined as feed line. So the feed line again the same, feed line width along x-axis, so minus FW by 2 to FW by 2. Then while defining here you must be careful, I should start from the quarter wave transformer extension, last part, from that part to the substrate end. So that's why minus PL by 2 to minus PL by 2 minus QL. So this is the minimum point. And where should I end? I should end at the substrate. So minus SL by 2. So with thickness is same. So T plus H. Then this is T plus H plus T, copper material. So now you can observe. See, this map patch, quarter wave transformer, then followed by feed. So next is, as I have constructed the structure, so go with the giving an input. How to give the input? Same procedure. Click on phase where you are supposed to give an input, port. So click on port. So first choose the phase which you need to. Choose the phase where you are supposed to give an input. So this is a portion where I am supposed to give an input. So that's why choose the phase where you are supposed to give an input. So go to pick. So pick our edge phase. So that means pick phase. I am supposed to go to pick phase, or otherwise you can select F. So F. So pick the phase and double click on the phase where you need to give input. Then while giving input, go to VBA home, VBA macros, solver, then ports. I am supposed to apply, calculate port extension coefficient, then construct a port from the picked phase, then close. So now you can observe under the ports, suppose if it is hidden, you can observe under the ports the input feed has been given. So feed line as we have provided. So component if you choose, so you can get now input I had provided, already input I had given, then patch constructed. So next step is going for a simulation. So go to simulation, check the frequency range 5 to 6 gigahertz, check the background, so it should be in normal position. Then boundaries which has created for the patch. So then go to setup somewhere. As now right now I am not going with any changes, so start as it is. It starts simulation. Then now as I have not applied, look for the S11 parameter, though then go for variation in parameters for achieving a higher S11 value. Then you can apply field monitors later. So we'll go with the first S11 parameter. Under navigation tree you can find 1D results. In 1D results, go to S parameters. So after completing the process, you can observe S11 value. So now you can observe S11 value. We have designed at 5.8 gigahertz, but we are getting at 5.5 or 5.5 to 5.3 like that. So I am supposed to increase the even observe. So it is minus 18 dB I am getting. The bandwidth is less than minus 10 dB. If you want to go for markers, curve marker, you can go with a curve marker. So this is first point, 5.52 I am getting. The bandwidth is see, this is first, second point and third point. So between these two, second and third difference is your bandwidth different. Then as the patch is not resonating nearly to 5.8 gigahertz, so you can change that by varying the patch length as well as the quarter wave transformer, because the impedance of uh, impedance of the patch antenna, as we have calculated, it is 258. For that quarter wave transformer impedance I am getting as 113. Suppose if this impedance is not same as that, then the quarter wave transformer impedance varies. Obviously QL value will, QW value will vary. So now I'll change the parameters. Parametric optimization you can go with. So parametric sweep. So you will be defining a new parameter or new sequence. New parameter will define. So I am supposed to vary the quarter wave transformer width. So width I will vary. You can specify the range. So 0.4932 some value. As I have simulated, I got the value, good value for from 0.4932 0.65. I am getting a good value. Here you can specify the range and you can apply for simulation, or otherwise this is one way, or otherwise if you know already, if you have done, then you can go with parametric variation here itself. So here I have changed for 0.65. I got a good results. That's why I've changed it directly to 0.65. Then it will ask for change in parameter updation. So parametric update once you do, so the parameter QW value will vary. As we have varied, I need to go with the simulation once again. The parameter QW value I have varied, you need to go with the simulation once again. So again check for the parameter of 1D parameter S11 value, S11 graph. For new parameter it will evaluate. Then similar manner, you can vary. If I want to vary the resonating frequency, you can vary for a different patch length. So you can vary from same way, go to parametric analysis. You can go for parametric analysis and you can cross verify. So you observe for 0.65 mm, I am getting a round curve marker. If you observe with a curve marker, if you observe, you are getting a good resonance. So 5.53 gigahertz is the resonating frequency now. We are getting around minus 28.4. So for 5.53 gigahertz, you can go for variation of a field monitors. Go to field monitor. So here you can find a field monitor. So create a new field monitor, not at 5.5, 5.53. 5.55 or 5.53, because the resonating frequency is 5.53. E field you apply, H field also apply at the same, far fields, then the surface current, whatever you need, you wish to observe. So create on that, create a field monitor for that. Then as it is again, I have created field monitors at different frequencies. You need to go with the simulation to observe the far fields. So the far fields you can observe over here, the 2D results you can observe over here. So I can go with the E field or H field at 5.53 gigahertz. So 5.53 is my resonating frequency. So at 5.53 you can go for field monitors. So you can observe the field in a proper manner by choosing a contour and dB to a maximum of 0 dB. You can animate the fields and observe. Similarly, this is E field. Similarly, H field you can observe. So go to maximum dB, then you can observe. Similarly, you can observe for the simulation surface current. So go to dB maximum, you can observe the surface current values. Now we are interested in finding out far fields. Click on far field. This is a 3D radiation pattern. Go for transparency. So means you can observe the patch also. So as nothing that much you can get from the 1D results. Go to 1D result. Then in the 1D result you can observe the parameter which you are getting is far field at 5.53 main lobe magnitude is the directivity which you are getting is 7.15 dp. So similarly you can go for far fields of direct instead of directivity gain. So the gain value is 3.49. You can evaluate the G by D ratio will give you the efficiency. So similarly, electric field, magnetic field, all the parameters you can observe. With this similar manner, if I want to vary any parameter, you can go with the parameter variation. The navigation tree, if you go to component, you can get the component and you can vary the parameters in the parameter list. Then go with the parametric analysis, observe the results. So thank you. Hope this video might help you out. This is a design of a patch antenna at 5.8 gigahertz. Observed all the simulation results. Thank you, Anna.